Hi students, welcome back. This is part 2 of the lecture on elasticity. And so we'll continue on with the topic of what is elasticity, how do we use it in economics, why is it important? And one of the big applications in business is discussing the relationship between the elasticity of demand and total revenue. And so we're going to use the example of a linear demand curve and give you a few examples. The main point is that elasticity can give businesses important insight into what pricing changes will do to the revenue of the company. Now, ultimately, we're going to be concerned about talking about the profits of a company, but profits are revenue minus costs. So let's go ahead and take a look about how we can use elasticity to interpret what will happen to total revenue. So here's a demand curve and a relatively low price. This is for, and hopefully you can see based on the way that it looks, that the idea is that the demand curve is supposed to be inelastic in this illustration. And you can see that at a price of 100 units are sold, and so total revenue is $100. It's the area of that rectangle that is defined by the point on the demand curve and the two axes. So now imagine the company raises the price of the product to $3 and they only sell 80 units because the quantity demanded falls to 80. But now you can see their total revenue, as represented by the rectangle, is $240. So the revenue is expanded. And so this is what's typical. If you're in an inelastic portion of a demand curve and you increase price, then you'll increase revenue. And if you think about it from a company standpoint, that's really valuable information, because if their costs are driven by the number of units they're producing, which is typically the case, then they can bring in more money and actually reduce their costs by increasing their price and reducing the number of customers they serve. And the idea here is that when demand is inelastic, the number of customers that you lose is relatively small compared to the increase in price. So on the customers that remain, you bring in so much more revenue that it more than compensates for the number of customers that decide not to purchase your good. So here you can see clearly moving from $100 in revenue to $240 in revenue is a good thing for the company. Okay, so what happens if demand for a curve is elastic instead? Well, then you get the opposite relationship. If demand is elastic, then you're going to lose a lot of your customers compared to the amount of revenue that you bring in from increasing your price. So total revenue is going to decrease. So now we'll take a look at a relatively flat or elastic demand curve. And we'll also look at an associated price change, a price increase of $1. And here you can see the change in the number of customers is pretty big. You go from a quantity demanded of 50, and by raising the price by only $1, you lose over half your customers. It drops to 20 customers. So you can see that the revenue rectangles that are defined by the points on the demand curve, the revenue rectangle after the price increase is a lot smaller, and that means that there's a big decrease in revenue. That's what happens when the demand curve is elastic. So the next table is an illustration of what happens along a linear demand curve. One of the things that is a little bit misleading about the way that we've talked about elasticity so far is that flat curves tend to be elastic and steep curves tend to be inelastic. But the truth is that every linear demand curve, whether it's steep or flat, has an elastic region and an inelastic region, and at the midpoint of the curve, or the midpoint of the line, it's unit elastic. So let's take a look at this table in detail. You can see that there's a demand schedule for the two left-hand most columns. It tells you the price and the quantity of the good. And if you start at a price of 7, then your quantity demanded is going to be 0. That's going to be the top of the demand curve. And then as we move down, for a price of 6, you get 2 units. A price of 5, you get 4 units demanded. And you move all the way down to a price of 0, where the maximum quantity demanded would be 14. So this is a linear demand curve. Every time you move down $1 on the price, you get exactly 2 more units in terms of quantity demanded. So that's a constant slope. This is a linear demand curve. And now you can look at the total revenue being calculated. I teach you the points on the demand curve. At a price of 7, it's 0. At a price of 6, the total revenue for the 2 units is $12. It's $6 per unit, and there are 2 units sold. And for a quantity of 4 at a price of 5, the total revenue is going to be 20, and so on. And then we can calculate our percentage change in price and our percentage change in quantity using the midpoint method. And then we can finally calculate our elasticity of demand. And remember, if we did this and there was a negative sign, we would throw it away for purposes of interpreting elasticity of demand. So you have elasticity. Remember, a value above 1 is called elastic. So for this linear demand curve, you can see the top of the curve above the midpoint is elastic in terms of the values of elasticity that you calculate in that region. And then as you move past the midpoint, it turns inelastic. So that's an important lesson. Every linear demand curve has an elastic and an inelastic region. So you can't just look at the curve and tell that it's an elastic or an inelastic curve. It's really what you're looking at when you're looking at the slope is if you looked at 2 curves, 2 demand curves that pass through exactly the same point on your graph, and one was steeper, then you would know that it was more inelastic than the flatter one. But if you're just looking at a curve by itself with no reference, you can't really tell by looking at it if it's elastic or inelastic. So now we move to a slightly different topic. We've covered elasticity of demand, and we've talked about why it's important for categorizing different regions of the demand curve and how it relates to pricing decisions that businesses might make and how it would affect their revenue. But there are other elasticities we can calculate too, not just the price elasticity of demand, even though that's the main one that we calculate. But these other elasticities, like the income elasticity of demand, what it does is it measures how much the quantity of a good demanded changes in response to a change in consumers' income. And you should remember that income is one of the main determinants of demand for a good. But we could calculate it as we did before, as the percentage change in quantity demand divided by the percentage change in income, in this case, instead of price. So it's still quantity demanded. And you can see the equation here. But here we have to be careful, because the sign matters. If we have an increase in income, which is a positive percent change, and we get a decrease in the amount of the good demanded, that's a negative change in percentage, then that whole ratio will be negative, and that'll mean that we're having an inferior good. The quantity demanded is negatively affected by an increase in income. So we've defined inferior goods already. Those are the goods that consumers only purchase because they can't afford something better. So when their income increases, they stop purchasing those goods. And normal goods, remember, those are the goods that if you have an increase in income, you also have an increase in quantity demanded. So the income elasticity for normal goods would be positive because both the denominator and the numerator would be positive. So again, the gist of it is that higher income is going to raise the quantity demanded for normal goods, but lowers the quantity demanded for inferior goods, and that's going to affect the value of the income elasticity. Goods consumers regard as necessities, remember, they tend to have inelastic nature to them, especially with respect to changes in income. So food, fuel, clothing, electricity, internet service, medical services, would be have a low value in terms of income elasticity. And consumers, if they think a good is a luxury, things like sports cars, furs, and expensive foods, well, then that's going to have a big number in terms of income elasticity. So now we can really differentiate between what do we mean by necessities and what do we mean by luxuries. It's not just the slope of the demand curve, but it's also this income elasticity measure that we can use to refine goods into categories. So if income elasticity is a small number, then the goods are necessities. And if they're a big number, something bigger than 1, then they would be goods that normally we would regard as luxuries. So a number less than 1 for income elasticity is a necessity. A number bigger than 1 is a luxury. Okay, and we can also likewise define elasticity of supply. Elasticity of supply is a measure of how much the quantity of a good supplied changes in response to a change in the price of that good. And so the price elasticity of supply is simply the percentage change in quantity supplied in this case over the percentage change in price. And we can again look at curves that illustrate the different possibilities. If you have an elasticity of 0, then that means supply is not responsive to changes in price. And this is an extreme example. A perfectly inelastic supply curve is vertical. And so as you change the price, there's no change in quantity supplied. If you have a relatively steep one, again, as you change the price, then the percentage change in quantity supplied is smaller than that percentage change in price. Here you can see a 22% increase in price only leads to an increase in quantity supplied of 10%. So that's going to give us, if you take the ratio 10 over 22, a fraction, some number less than 1. You can also have unit elastic supply curves where you get the same percentage change in quantity supplied for a percentage change in price. So in this case, you can see it's 22% increase in price is a 22% increase in quantity supplied. And if you have an elasticity that's greater than 1 for supply, then you're getting a bigger increase in quantity supplied compared to the increase in price. And then you have the perfectly elastic supply curve. And again, what this means is that producers will produce any quantity at some price that's 4 or below, but as soon, or excuse me, 4 or above, but as soon as the price drops below 4, then they stop supplying at all. So how do we interpret elasticity of supply? Well, the ability of sellers to change the amount of the good they produce is really what's in question. If you look, for example, at the elasticity of supply for beachfront property, well, it's inelastic because you can't get any more. Even if the price goes up a lot, what can you do? You can't change the coastline. And for lots of regular goods like books, cars, and manufactured goods, the elasticity of supply tends to be elastic. As the price goes up, then producers can actually produce more. And if we take a look at the time period, that's important too. Sometimes suppliers require time to respond to changes in price. So if we measure supply over a long period of time, like a year or two, and the price stays higher, then you're going to, or stays high, then you're going to see a big response. Suppliers will have time to react to it. But if it's a really short period of time, then supply is going to look inelastic because suppliers don't have enough time to respond. So we still have the exact same formula, except for in this case, it's the percentage change in quantity supplied instead of the percentage change in quantity demanded for the elasticity of supply. And so you can see the equation there. And next, one of the things that we want to talk about is a little bit of an application of elasticity of supply and demand. So one of the things that happens a lot is when something happens, like there's really bad weather, and it destroys a lot of agricultural product like tomatoes or oranges. That may seem like it's bad news because you know there's going to be reduced supply. But the question is it really bad news for farmers in the sense, is it going to mean more money or less money for them? We kind of have an idea, but really what it depends upon is the elasticities of supply and demand. Well, we know when you're harvesting a farm product, right, you've planted however much you're going to plant at the beginning of the year, and depending upon the weather and other factors, you're going to harvest whatever grows. And if bad weather cuts the supply, you're going to have this perfectly inelastic supply curve. And so what's going to determine the amount of the money that the farmers make is just the elasticity of demand, which is how much consumers are willing to pay for a smaller amount of the good. Are they going to drive the price up or not? So for example, we could ask in the context of wheat, what happens to wheat farmers and the market for wheat when a university agronomist discovers a new wheat hybrid that's more productive than existing varieties? Well, this is the case where you're going to have an increase in supply from a technology, right? So again, is that going to be bad or good for the farmers? Well, it depends upon how much it increases the supply of wheat. If wheat is elastic and it increases the supply a lot, then it's not going to generate much more revenue for the farmer. So what we have to do is examine whether the supply or demand curve shift and determine the direction of the shift of the curve, and then use the supply and demand diagram to see how the market equilibrium changes. So let's go ahead and take a look at that. Here we have a demand curve and a supply curve for wheat. Now, this would be a situation where there is time for the sellers to react somewhat, right? If they see a high price, they can produce a little bit more. So we don't have a perfectly inelastic supply curve. But you can see that the supply and demand curves look relatively steep or relatively inelastic. So here you see the initial equilibrium is at a price of $3, and they're selling a quantity of 100, which might be like 100 tons of wheat. And then the demand for wheat is supposed to be inelastic, and so you have an increase in the supply of wheat, and it drives the price down, but the quantity sold isn't very much. So this is one of those examples where you're in an inelastic region and you decrease the price, and as a result of that, you pick up a few more customers, right? But you don't make much more revenue. So that's bad news for farmers if you increase the supply. And you could look at the opposite case of, a crop being wiped out, a lot of it, and decreasing the supply, which would be good news for the farmers because they would end up collecting more revenue. So we can calculate this using our elasticity of demand with the arc elasticity or the midpoint method. And you can see we end up with this, and we would disregard the minus sign. But in the region of the demand curve on the prior slide, you can see that the elasticity of demand is a number that's less than 1 in absolute value. So it's inelastic in that region. So actually, right, our conclusion would be that something that increases supply for the farmers would decrease the amount of revenue for them, and which would be bad news from the farmer's perspective, even though it sounds good that you're increasing the supply of wheat, but the farmers are going to make less revenue. And if you have something like bad weather that destroys a lot of the crop in this inelastic region, it's actually going to mean more revenue for the farmer. So that's the gist of that application. Is a lot of times when it sounds like something bad has happened to farmers, it actually means they're going to make more money because the price of the product is going to be driven up by a restriction in the supply. So that's it for our lecture on elasticity, and I'll be talking to you soon.